Hi viewers, welcome to this new video lecture series. I am Dr. Gopi Krishnan, Associate Professor, Department of Aerospace Engineering at SNS College of Technology, Coimbatore. In this video lecture series, we are going to see the advanced kinematics of mechanisms. We start with the kinematics of gear mechanisms and motion transmission for this session. Come, let us join the video. Hi, welcome to this video lecture number 1. So this is going to be the video lecture which gives the basic introduction and terminology behind the gears in kinematics. And gears, what are gears? The gears are the toothed mechanical components. So this is going to be the component which transmits the motion and power to the other component. So when the components are transmitting the motion and power, those components can be called as the mechanical components. And these gears are called as the toothed mechanical components because the teeth-like structures are cut over its periphery, over its outer geometry. So the gears are called as the toothed mechanical components. And why they are designed? Because in order to transmit the motion and the power between the different shafts with some distance, we require the mechanical components, and this is done by the gear mechanisms and gear components. And how to transmit the motion and power? It has to be transmitted with absolute precision and zero slip. So this is the basic definition of the gears. And what are the gears going to do with the system? Number one, it's going to transmit the motion. It bridges the physical distance between the rotating input and output axis. Number two is modifying the speed, that is whether the transmission can be in the same speed or the reduced speed or the maximum speed. Number three, alter torque. So torque and speed are interconnected. When you want to increase or when you want to decrease the torque, it can be done by the usage of the gear components. Number four is change direction. If you want to change the direction to the clockwise or to the anti-clockwise, it can be done by the introduction of the gears in the system. Let's come to the basic terminologies that determine the motion and the power transmission between the two gears. And we have a number of basic terminologies, but these five are very important as far as the content is considered. Number one is pitch circle, which is all about the theoretical circle. That is, this is going to be the circle which does not exist. This is going to be the imaginary circle. It is used for the theoretical purpose for doing all the calculations. So pitch circle is going to be the circle that lies at the exact center of the teeth of a particular gear. Number one. Number two is all about the addendum. Addendum is going to be the radial distance from the pitch circle to the top of the tooth. Whereas dedendum is the radial distance from the pitch circle to the root of the teeth. Number four is module, which is given as M. That is the ratio of the pitch diameter to the total number of the teeth. And the importance of module for a gear system is all about the gears can be either small or large, but these two gears can be meshed together or joined together. That is, the physical contact between the two gears can be made together even if they are small or large in number or different or with the different sizes. But the only condition is that both the gears, either the small or the large gear, are the same, or both the gears must always have the same module irrespective of their sizes. So it gives the significance of this factor module. And number five is all about the pressure angle, which is the angle driving the direction of the force transmission between the meshing profiles. So these five basic terminologies are very important when we do the calculations for the power and motion transmission of a gear. So let us come to the fundamental law of gearing, which states that the motion transmission requires a constant trade-off between the rotational velocity and the mechanical force. So the gears are meshed together, and when the gears are meshed together with different sizes of the gears, we have the different velocities at the output considering the input. So the gears with teeth T1, number of teeth, that is T1 is meshed with the gear with uh, teeth number T2, right? Say for example. Then during the input, when the input gear, which is also called as a driver, is having N1 speed in RPM, then the output taken from the driven gear is taken as N2, right? So these are the basic terminologies we require. So for the gear 1, when the speed is given to the gear 1, it is taken as N1, and when the speed is obtained from the gear 2, it is called N2. Similarly, the number of teeth of the gear 1 is T1, and number of teeth of the gear 2 is T2, right? If you take the fundamental of gearing calculations between the number of teeth and the rotational speed, then we get another formula called gear ratio, which is all about the ratio between the rotational speed of first gear to that of the second gear, that is N1 by N2. So gear ratio is equal to N1 by N2, which always starts with the rotational speed in the numerator and rotational speed of the second gear in the denominator. All right. This notation N1 by N2 is always equal to the ratio of T2 and T1, which is all about the ratio between the number of teeth of the gear 2 to the number of teeth of the gear 1. So when summarizing these two concepts, we get the gear ratio, which is all about gear ratio is equal to N1 by N2 is equal to T2 by T1. So which means that when the speed of the gear decreases across a meshing set, the torque capacity exponentially increases because speed and the torque are inversely proportional. We will see the rest of the concepts in the next video. Thank you.